Hi everyone, today we're going to be looking at what an equation is. We've talked a little bit about them before in terms of expressions and equations, but today we're going to have a look at what actually makes an equation. And the answer to what makes an equation is actually very, very simple. If something has an equal sign, it's an equation, okay? An equation is just two expressions that are separated by an equal sign. Now, it doesn't have to be true to be an equation, it just has to have an equal sign, okay? So if we had a look at these examples below, I've got 21 plus 15 equals 36. Because of that equal sign, it is an equation, okay? Yes, it is, and it's also true, okay? Because we know that 15 plus 21 will give me 36, so that is an equation, okay? Looking at 21 minus 9, once again, is that an equation? It has an equal sign. Very simple. Yes. If we wanted to go further and see if it was true or not, 21 take 9 will in fact give me 12. So we know that is also true. Moving on to that third one, we've got 21x plus 73. There is no equal sign, so it is not an equation. Okay. This fourth one here, once again, I have two expressions separated by that equal sign. Yes, it is an equation. We don't know if it's true though, because we don't know what u is, but we do know it's an equation. Lastly, we've got that lovely expression there. No equal sign means not an equation. So even if it looks like it could be an equation, you're really just looking for, is there an equal sign? Yes or no? We're going to take this one step further now, and we're going to look at if it is true or not. Okay? Looking at if something's true or not, we're just going to look at if that left-hand side of the equation matches the right-hand side. So if I go through the motions, if I calculate that, are they the same thing? Okay? So let's look at this one here. Remember to use your BODMAS. That's going to be 14 times 1, because we do brackets first, equals 9 plus 5. And then if I calculate both sides at the same time, I'm going to have 14 equals 14. So this is true because that left-hand side and the right-hand side are both 14. Okay, pretty simple. If we have a look at this second one, this one requires a little bit of substitution. Okay, so we've got to do a bit of working out, and don't forget to use your brackets just so we don't mix up any multiplications and that sort of thing. So this left-hand side is going to be 10 plus 4, and that right-hand side, don't forget to use your brackets, is going to be 3 times 4 plus 1. If you need to write your time sign in there, feel free to, okay? 10 plus 4 gives me 14. If I do 3 times 4, that's going to give me 12 plus 1. I get 14 equals 13. That is a false equation because they are not the same, okay? Because our left-hand side is 14 and our right-hand side is 13, they are not true. Last one here, we've got two things to sub in. Might be true, might not be, we'll find out, okay? I'm going to sub in my x equals 2 into here, and I'm going to sub in my y equals 8 into here. Going through the motions, I've got 3 plus 10 equals 21 minus 8, and some of you might have already seen that'll give me 13 equals 13, and it's true because they are both 13. Okay, so you're just really seeing if that left-hand side matches the right-hand side or not. For the last little bit, as with everything else in maths, we need to be able to do some worded problems, okay? You should be able to just write equations given a description. If you want to go a step further and solve them today, you absolutely can, or you can just focus on the writing of the equation. Some keywords to note are things like sum, product, quotient would be division if that popped up, and also watching out for fractions and that sort of thing. If I look at example A, we're looking at the sum of two things, remembering that sum is plus. So that's going to give me x plus 5, and they're saying that is 22, so it's equal to 22. Okay, is means equal. For B, I've got a number of cards in a deck is X, and in 7 decks there are 91 cards. So I've got 91 cards, and I'm splitting that up into 7 different decks. So what I'm going to actually be doing is dividing x by 7. Oh, my bad, sorry. I'll be multiplying x by 7. Oh, goodness gracious. And that would give me 91, because if I then split that up into the 7 decks, I'll have my number of cards per deck. This last one here is a little bit of a trickier one. It does involve some fractions, okay? Matthew's earning $W per year, so he's earning some sort of amount. He spends 1/12 of this on books and 2/11 on food, and the total amount he spends on books and food a year is $15,000. Because that total there is $15,000, I'm going to go ahead and put that on my left-hand side, okay? Because we've got that equal sign in the middle, the left and right-hand side are interchangeable, okay? So they can be either way around. It doesn't really matter. If I want to say he spent 1/12 of his money on books, I'm going to do 1/12 times W is what we've been given. And then 2/11, I'm going to be adding that on times W. And then don't forget, because we're working in algebra, I can just get rid of those multiplication signs and have 1/12 W plus 2/11 W. And if you're that step further and are happy to simplify, you are more than welcome to go and do that. Okay, but we'll leave it at that one for today. Pause here and have a go at the ones on the right-hand side, and then unpause and I'll go through them. If we're looking at the product of something, that is multiplication. So I'm going to have 3 times A equals 21, which means because we get rid of that multiplication sign, 3A equals 21 is the nicer way to write it. Next, we've got Natalie's age. At the moment, she's A years old. We don't know what A is. And in 5 years' time, her age will be 17. So we know that we're going to have equals 17. If I'm going 5 years into the future, I'm going to add on 5 years from now because she's currently A years old. So that means we would end up with A plus 5 equals 17. And then C is quite tricky, just like the other C was. We've got John, he's got M marbles, and Michael has B marbles. And when they combine their collection, they're going to have 150 marbles. So I'm going to put 150 on that left-hand side there. Don't forget, it doesn't matter which side the pronumerals are on. If John's going to add in half his marble collection, that means I've got half times M, okay? And then Michael's got B marbles, but he's just going to put in 1/4. So that's going to be 1/4 times B. And then don't forget, we can then simplify that down without using multiplication signs.